Okay. There was a question on mass balance for wastewater treatment plants. One of those questions was, which one you ask? Is that for primary or secondary? Primary is easy. But anyway, let me write every mass balance equation so that we understand. There are, so as you see in the wastewater treatment plants, you have three different sections. One is primary clarifier, which is a, hold on, my screen doesn't work now. Let's see. Okay, Apple Pencil connect. Let's see, maybe the Bluetooth is on. Oh, yeah. Okay. For some reason this doesn't work. Okay, now it works. So this is the primary clarifier. So you have something coming in. So I'm just going to write it here. Q is the flow rate, and let's write S in. Okay, that's the amount. And let's write X in. X in is the amount of suspended solid coming in. So this is from, let's say, urban area. So like household, all those things. So this is particularly given to 30,000 or 20,000 people. All that, based on that, you can calculate all these Q and S in. F in is BOD. This is suspended solid. TSSS. That's basically they call TSS, suspended solid. So that's how we know what is X. And this BOD is given as BOD 5 or BOD. If you use BOD 5, use for everything. That way you calculate whatever number you get is BOD 5, not BOD, total BOD. Okay, so now if you see in primary clarifier, you have something coming in and there are two output. One is this, another is the waste here. This is waste. So only thing you have to remember here, primary clarifier, that 35% of all the BOD is removed. So that's the number is like we assume all the time. So that means 35% of S in is removed. So how much BOD is removed? What's coming in is Q times S in. That's the what's coming in. And then what's removed is 35%. So that means 35 times this is removed. Total amount removed, because this is the mass, Q times S in. And that means another way to say is if your flow rate is same, and assume that the flow over here is there no water. That means your water flow rate is not going to change. That's why you see the Q value doesn't change from to here to here. The reason is you are removing solid, you are not removing water volume. So that's why the flow rate is constant, same Q coming in. And then what happens is S in become S0. So how much that become, because your Q is not changing, usually you can write that if it says, let's say that PC remove typically 35% BOD typically, but check that in the questions. Sometimes it says 40%, sometimes it says 30%, but that number is usually given, or you can assume that usually it's given. So that means S0 would be equal to that 35% of S in. Okay. That's how you can calculate S0 if it's not given. And so that's the mass balance for primary clarifier, which is not the critical thing a lot of times, because those are just number given. What a lot of times you will do is writing the mass balance for the secondary clarifier. So to do that one, so secondary clarifier, if you see, this is the control volume. If I draw that one, the boundary, there are three things coming in and going. Okay, so that's one is, if you see what's the flow rate here is what's the flow rate here? Let me write in Q. What's the flow rate here? So Q would be, so this same Q is coming in, and you see this is QS here, and this is QR. So this will be QS plus QR. And you see this Q is coming in, so it has to be same. If you do the mass balance here, Q has to be QS plus QR, because this is QR coming in. Two flow mixed together become in the same pipe. So that's the same flow has to go in. And in that context, if you do mass balance here, flow rate here is going to be QW plus, if you write this one flow rate here, whatever going in, out here is QR, this side. This is QW. So that means this bed has to be Q plus QW plus QR. This at that spot. Okay, because then it becomes two place. And the concentration doesn't change. They are just one pipe become two pipes, right? So that's why the concentration is same. So what you can say is SW is going to be same as SR, and QW is going to be QR. Oh no, I'm sorry, not Q, the concentration. So that's the BOD concentrations. XR is going to be XW. Because basically imagine it's one pipe is coming in, you're just two pipe going through. So that's this is the assumption. Okay. The flow rate is a fact. So that's the mass balance for flow rate. Okay, that's anywhere you want to do flow rate mass balance, this is the mass balance. Another mass balance you can do, what if you are going to do the mass balance for the entire secondary treatments, means mass balance. I'm writing flow mass balance. Okay, I'm not doing any concentration yet. Mass balance for secondary treatment. Secondary treatments means that include activated sludge basin or aeration tank plus secondary clarifier. Okay, both. So that means if you do control volume here, this is the entire thing. That includes both, all of them. That means you have one flow, which is the flow rate coming from primary clarifier, and there are two flow coming out. One is effluent wastewater, which is treated. Another is just the wasted activated sludge. So this is become waste, which is enriched with a lot of solid. And this is just a treated wastewater, and this is incoming wastewater from primary clarifier. Everything else, this inside, this is just recirculation. So that's part of the entire treatment. So if you do flow rate mass balance for that, then what is coming in has to be what is leaving the system. So that means Q, which is coming in, has to be QE plus QW. Okay. And if you do flow mass balance, if you do the same thing, concentration mass balance, for the entire secondary treatment. So what is in equal to out, right? So what is in here? Let's say we do first S mass balance. What is coming in is Q S0. That's what coming in here. Okay, this is what's coming in. And then what's leaving the system is this two. One is the treated wastewater, another is the sludge. So that will be, I'm sorry, equal to what's leaving the system is QE S0. There is a mistake here. This is not S0. It has to be SE, because S0 is treated already. So you don't really, that's the amount. So that's the notation is missing. So this is SE plus QW times SW. Okay. All I'm saying is the amount of, so this is basically amount of BOD is coming into the secondary treatment units. This is what's living in the wastewater, and this is what in the waste itself. So this is effluent, this is waste, and this is in. And BOD is not produced. Okay, BOD is destroyed, and that is inside the. Hey, I have a meeting. I can talk to you later. Sorry, I accidentally said yes because I was thinking I was disconnecting the phone, but it's ended up accepting. Okay, so that's the mass balance for the whole systems. Okay, and so this is influence. This is all waste. And another thing you can think of is what happened to the BOD here inside the reactor. Okay, this is influence. This is basically what is coming in, and this is what is leaving the system. But there is a reaction going on. So that reaction term, I'm just going to write where is the concept. Okay, this is plus the reactions. So reaction is happening only inside. So if you see any BOD is destroyed inside this system, activated slurs. So that means what is the reaction is going to be volume time reaction rate. And so reaction is basically, or whatever the concentration is inside here. Let's write reactions, that way you can. Then we can go to the actual in. Same thing if you do for the suspended solid, you are going to write the same way. So this is going to be X0 QE XE because solid is produced. Suspended solid could be produced because of the growth of microbial growth. Reaction, or I'm just going to write here, actually to make it more accurate, growth, because that's what growth in aeration tank. That's where it grows. So this is how you can do for the entire thing. So let's see. If you do just the secondary clarifier, this is what is asked. Steady state and no reactions. Secondary clarifier, as you see, if you're just doing that one, you have one incoming, which is this. We write about that, which is this Q, and then the concentration will be same thing as, it doesn't change from reaction. Whatever the inside the reactor, it will be in the outside the reactor. So this is the concentration, this is the flow rate. So that's coming in. So this will be in for here, and there will be two out one, and this will be out two. Okay. So that's what is written here. This is what is written here, QX. Okay, so let's see. What's coming in is okay, so based on how the notation is given, I don't know whether this QS is written as QS including this. I mean, QS can be including Q plus QR, or this is QS as a separate one. So we, the way it is written here is that Q is whatever coming in here. So based on your assumption, you can think of what is the number. And in this way, I wrote the same way as Q equal to QS per QR, assuming that this Q is same as this together. So that if you write that one, this will be Q plus, this will be QR plus QS, which is Q. Okay. So that's in. And what's leaving the system is this. This is out. In treated wastewater. And this is, if you see, this is QW plus QR. That's basically how much waste is leaving the system. That's settling. This is in, out, in, loss. Okay, that's settling basically. And the concentration is this, because you are assuming XW is same as XR. That's the assumption, because it's just there is no reaction going on. It's just the pipe is getting to different place. So this is one mass balance for secondary clarifier. There is another mass balance which account for the settling velocity. So instead of saying how much is being flowed out of the system, you are saying that, okay, if I don't, it's all settling, whatever settle is what's flow rate. So you just replace this one by settled mass. Okay, so because that's you are assuming whatever settle is what's removed as a flow. So if you replace that term with the settling velocity, this is what you get. Everything else is same. So again, as you see, this is, I wrote QE here. If you see, this is more accurately writing QE, and this is Q is equal to QS plus QR, the same as Q, just so that it's consistent across here. Okay, this is Q equal to that. And so this is all, and then the amount settled is basically this value. And that's I explained in the previous another time. Basically, amount of settle is basically concentrations, volume, let's say dm by dt, which is settled mass rate. Mass of the concentration settled is basically d by dt, volume of water that is being settled within that times, and the concentrations. So concentration inside is Xe. Okay. And basically, if you know that, if you see what is settled in the clarifier, if you see this is a clarifier, things are settling, then basically this is the area of the clarifier, that's the water area. And this is the way it is settling is moving in this direction. So this is the direction, settling velocity in this directions or height. Okay. So that will be area of clarifier, volume will be area of clarifier, and the settling velocity in the direction of G times Xe. And you know that area is basically constant because as the area doesn't change. So area and concentration you can assume constant because that's the treatment. So A X E out dG by dt. That's basically how quickly they are settling, the velocity. So this will be A Xe velocity of settling. Okay, so this is velocity of settling. That's why it's written here. So when you write the mass balance equations for clarifier, secondary clarifier, you can use this one if you are asked to calculate the settling velocity. And you can use this one if you are asked to calculate solve for QR or QW, because that's the term there. So in this equation, QS means Q plus QR. Yeah, how it is interpreted. But the way I wrote here, it says that basically Q is coming here, and that become, you know what? Right. So if you see what's going on here, Q is coming here, then QS is leaving, then QR coming in here. So that means QS will be Q plus QR, not not the other way around. So I made a mistake. So I'm going to write it that way. Because this is in, this is in, this is out. In that context, it will be Q plus QR is equal to QS. So what is written here is correct. And then the only thing that will change is the other one here. So that will be, this will be QS, not the, this one will be actually QS. Okay. So as you can see here, this is Q. So if you do mass balance here, this is in, this is in, this is out. So QS would be Q plus Q1. Yeah. Okay, so that's the mass balance for secondary clarifier. And if you see, here you do the mass balance for the entire secondary treatments. What they do is basically in, which is this case, in equal to, in equal to out. And what is coming in, this is in, and this is based on this, the way it is written. That's why there is a lot of things are written. So what is coming in and what is leaving the system. So if you see, or how the microplastic, how the amount of suspended solid is created. So this is a, or another says this is a in plus what is created in the system. That's the amount total coming into the system. Okay, it's same as what is out inflow plus settled. So there are two out. One is the wastewater treatments. That's this is basically in wastewater, treated wastewater. That's one plus sludge. That is the cycle. So this is the two output. So that means plus created quarter living in treated water and in sludge. So if you write what is in coming in is basically Q times TSS in. Okay, so that's basically another way I'm going to make it correct way. So this is, let's say, entire wastewater treatment plants. Okay, wastewater treatment plant. So this is coming in. So this is Q, TSS in, and BOD in. So that is coming in. And this one include primary clarifier plus aeration plus secondary clarifier, all three together. And then you have one unit leaving a system, which is basically out. And basically treated with, this is treated wastewater. So the concentrations is given here. Okay, BOD, TSSE, and QE. So that's QE, and the concentrations are TSSE, BODE. And then there's the sludge. So this is basically sludge is flowing at certain direction. That's basically M dot. M dot is basically amount of sludge removed. So dm by dt, amount of sludge flow through the system. sometimes, and that how much amount of sludge settle is basically because of settling. So m dot is because of settling. And what is happening inside is the reaction. All the reactions are happening inside. That reaction, if it's BOD, then they are basically destroyed. And if it is a suspended solid, that's basically created. Okay. So let's see how much what you write for this one. So TSS in is basically what's coming in. And then how much TSS or suspended solid created in the system in aeration tank, because your BOD is coming in, that creating the amount of things coming in. So that's basically flow rate time what's the rate at which they are created. So created is basically d TSS by dt. And this d TSS created is basically, if you see, that's related to this TSS delta TSS created. This is only created is related to while yield is basically ratio of amount of TSS created per unit consumption of BOD destroyed. So that yield times delta BOD. Okay, whatever the BOD consumed. So or treated. Okay. So that's why it's basically what you're writing here is this one. Yield time difference in BOD. And that's the number you are written here. See, this whole thing is this term. And then what is living in that wastewater is this one. It's right here. So treated, this is the out in the effluent system. This is basically QTSSE that's come leaving the system. In this case, this is QE actually. So this is QE plus M dot S. Okay. So that's written here out. So this is again in example homework, just check those, and everything else is written here. And there is another mass balance equations. Aeration tank mass balance. Basically, you are doing mass balance only on this one. This one. So your one is coming in, one leaving the systems, and then the reaction is going on inside it. So as you see over here, what's going on here is that whatever amount produced, this is basically growth. Amount of bacteria grow in the system has to be related to what is coming in minus what is leaving the system, or what is being, because whatever things are grown is related to how much BOD is consumed. So that's exact, again, same thing that we did before. Let's see what is that. Okay. No other things. Just trying to see if there is anything miss. I'm just going to suggest that now look for this example homework. That's where we derive all the mass balance. Example homework 5. So if I see what is that in the folder, let me check that. Example 5. So this is the documents. In these documents, we have written all the mass balance equation. For instance, this is a mass balance equations. This is a mass balance equations. You can see this one. This one we actually use that other. Then another mass balance equation is, and they're all fail. Like here another overall mass balance equations here. Whatever homework, will not ask in a different way. And these are example also given. So it says aeration tank biomass balance equations. So this is the equations. And check the question so that you know how the figures are drawn. Figure 4. 1, 2, 3, 4. Okay. Just going to stop sharing. I'm going to stop recording.